So welcome, this is the video based on variable acceleration, part 2, past paper questions. The first question, a particle P moves on the x-axis at a time t, the acceleration is given as, phi minus 2t, is measured in the direction of x increasing. When t equals to 0, v equals to 6. Find the time at which it is instantaneously at rest. What do I mean by instantaneously at rest? When the velocity is 0. So first of all, acceleration is given. So acceleration means dv upon dt, which is phi minus 2t. So dv equals to phi minus 2t dt. Then I find the integral for that. Integral of dv becomes velocity equals to phi t minus 2t square upon 2 plus c. But we know that t equals to 0, v equals to 6. So 6 equals to 5 times 0 minus 0 square plus c. This gives me c value as 6. So what is the equation of the velocity now? Velocity equation is t square minus phi t, or phi t minus t square, phi t minus t square plus 6. Now instantaneously at rest. At rest means velocity equals to 0. So phi t minus t square plus 6 equals to 0, which gives t square minus phi t minus 6 equals to 0. Factorize it out, t minus 6 times t plus 1 equals to 0. So t equals to 6 or t equals to negative 1. As the time cannot be negative, so the answer is going to be t equals to 6. Coming to question number 2, a particle P moves on x-axis, and between 0 to 4 seconds is one equation and greater than 4 seconds is the other equation. At t equal to 0, the P is at origin. So find the greatest speed of V between 0 to 4. So what is the equation given? V equals to 0 to 4 is V equals to 8t minus 3 upon 2 t square. Maximum speed means the derivative should be equals to 0. So dv by dt, which is nothing but what, 8 minus 3 upon 2 times 2t, so which is 8 minus 3t should be equals to 0. This gives me t equals to 8 upon 3 seconds. But what is he asking? What is the greatest speed? So plug in this value of t in the velocity. 8 times 8 upon 3 minus 3 upon 2 times 8 upon 3 whole square, which is 32 upon 3 meters per second. The distance of P from origin when t equals to 4. So in order to find the distance, we need to find the integration. So V is 8t minus 3t square upon 2. So I am going to find the integral of this one. It becomes ds, because this is ds upon dt. ds equals to integral of 8t minus 3 upon 2 t square dt. So s equals to 8t square upon 2 minus 3 upon 2 times t cube upon 3, but it is asking from 0 to 4 seconds at t equals to 4 seconds. So, and at t equal to 0, P is at origin. So I write plus C over here. So S equals to 4t square minus t cube by 3 plus C. But t equals to 0, S equals to 0. So 0 equals to 0 minus 0 plus C, which gives me C equals to 0. So what is the equation of the distance? 4t square minus t cube by 2, not by 3. It should be by 2. So I want at 4 seconds at t equals to 4. So plug in distance equals to 4 times 4 square minus 4 cube by 2, which is going to be 32 meters. Part C. The time at which P is instantaneously at rest for t is greater than 4. So t greater than 4. The equation is 16 minus 2t. That's the velocity equation. That should be equals to 0. So which gives 2t equals to 16, t equals to 8 seconds. Coming to part D, the total distance traveled in the first 10 seconds. So we come to know that first 10 seconds. So from 0 to 4, we have already calculated the distance was 32 meters. 4 to 8 seconds, it becomes rest at 8 seconds. And again, we have to find it out a distance between 8 to 10. So we have to find it out three parts, first part, second part, and the third part. Because at 8 seconds, it becomes at rest, so it will change the direction of motion. So for 4 to 8 seconds. 4 to 8 seconds, 16 minus 2t dt. So which is 16t minus t square from 4 to 8. So 16 times 8 minus 8 square minus 16 times 4 minus 4 square, which on simplification, it should become 16 meters. Now from 8 to 10 seconds. 8 to 10 seconds, 16 minus 2t dt. So it becomes 16t minus t square from 8 to 10. So plug in 16 times 10 minus 10 square minus 16 times 8 minus 8 square. Plug in, you'll be getting it out negative 4, but actually the distance will be positive 4. So the total distance will be 32 plus 16 plus 4, which is equals to 52 meters. Coming to question number 3. Velocity is given for two different times, 0 to 6 seconds and greater than 6 seconds. At t equal to 0, p is at origin. Find the displacement of p when t equals to 6 seconds. So 6 seconds means I should take the first equation, find the integral 10t minus 2t square dt. So it becomes 10t square upon 2 minus 2t cube upon 3 plus c. Now at t equal to 0, p equal to s equal to 0. So 0 equals to 0 minus 0 plus c, which gives me c equals to 0. So now plug in t equal to 6 or s equals to 5t square minus 2 upon 3t cube plus c was 0. So at t equals to 6, it becomes 5 times 6 square minus 2 upon 3 times 6 cube, which becomes 36 meters. That's going to be the answer. Now for 10 seconds. 10 seconds means I should be taking the second equation. So s equals to integral of 432 t power minus 2 dt. So it becomes minus 432 t power minus 1 plus c. Now we know that t equal to 6, s equals to 36. T equals to 6, s equals to 36. So 36 equals to negative 432 upon 6. But the equation is itself was having negative, so it becomes positive. So plus c. This c value gives me as negative 36. So what is the equation of the distance? 432 upon t plus or minus 36. Now t equals to how much? T equals to 10. So s equals to 432 upon 10 minus 36, which is 7.2 meters. Now coming to question number 4. At t equal to 0, a particle p leaves the origin and moves along the x-axis, means t equals to 0, s equals to 0. At time t second, the velocity of p is given as v equals to 8t minus t square. What is the maximum value of p? So in order to find the maximum value of p, what is that we have to find it out? The first derivative should be equals to 0. So dv upon dt equals to 8 minus 2t. That should be equals to 0. 8 minus 2t equals to 0. So t equals to 4. Plug in t equals to 4. 8 times 4 minus 4 square, which is equals to 16 meters per second. Find the time taken for p to return to O. Return to O means, what is the meaning is displacement should be equals to 0. Displacement should be equals to 0. So first of all, what am I going to do it out? I am going to find the distance by doing the integral 8t minus t square dt. So what does that becomes? S equals to 8t squared by 2 minus t cubed by 3 plus c. So S equals to 4t square minus 1 upon 3 t cube plus c. But we know that it is t equals to 0, it is starting from origin, s equals to 0. T equals to 0, s equals to 0. So 0 equals to 0 minus 0 plus c. So c equals to 0. So what is s? 4t square minus 1 upon 3 t cube. Now what is it telling? It has to return back. It has to return back means at a particular time t, it will return back. So the total displacement should be equals to 0. Take t square common, so it becomes 4 minus t upon 3 equals to 0. So 4 minus t upon 3 equals to 0, or t equals to 0, which gives me t equals to 12 seconds. That's going to be the answer. Question number 5, or t equals to 12 seconds, then find the time taken to return. So answer is going to be 12 seconds. Question number 5, a particle p moves along x-axis at the time t seconds. The velocity is given v equals to 3t square minus 4t plus 3. At t equal to 0, p is at origin. Find the distance, means t equal to 0, s equals to 0. Find the distance of p when p is moving with the minimum velocity. So first of all, find dv by dt to find the minimum velocity. 6t minus 4. Minimum velocity means at the minimum point, the first derivative should be equals to 0. Acceleration is 0. So 6t minus 4 equals to 0. T equals to 2 upon 3 seconds. So whenever at minimum or maximum, the first derivative should be equals to 0. So time equals to 2 upon 3. Now, but what is he asking? Find the distance. So we have to find it out. The equation for the distance, which is integral of 3t square minus 4t plus 3 dt, which is t cube minus 2t square plus 3t plus c. But we know that t equals to 0, s equals to 0. So s equals 0 equals to 0 minus 0 plus 0 plus c. So c equals to 0. So what is the equation? T cube minus 2t square plus 3t. But now I have to find it out the distance at 2 upon 3 seconds. So plug in 2 upon 3, 2 upon 3 whole cube minus 2 times 2 upon 3 whole square plus 3 times 2 upon 3. Simplify that, you should be able to get 38 upon 27 meters. Question number 6, a particle p moves on the x-axis. The acceleration of p at a time t seconds is given by acceleration a equals to 3t plus 5. When t equal to 0, the velocity is 2 meters per second. When t equals to t, the velocity t equals to t, the velocity equals to 6. Find the value of t. So first of all, I'm going to get the velocity equation. For that, I'm going to do the integral 3t plus 5 dt. So velocity equals to 3t square upon 2 plus 5t plus c. We know that t equals to 0, v equals to 2. So v equals to 0 plus c. This was c. So what is the value of c? C equals to 2. So velocity equals to 3 upon 2t square plus 5t plus 2. Now velocity is equals to 6 at t, capital T, 3 upon 2t square plus 5t plus 2. Multiply entire equation with 2, so 12 equals to 3t square plus 10t plus 4. So 3t square plus 10t minus 8 equals to 0. Now this is a quadratic. Factorize the quadratic. So I add a page over here. It's not getting added up there. So I find the quadratic equation, factorize it out. 3t minus 2 times t plus 4 equals to 0. So I get t equals to 2 upon 3 or negative 4. Time cannot be negative, so answer is 2/3 seconds. Question number 7. A particle moves along the x-axis at t equals to 0. A particle passes through origin with a speed 8 meters per second. T equals to 0, velocity equals to 8. The acceleration of the particle at a time t seconds is given by acceleration is 4t cube minus 12t. Find the velocity of the particle at t seconds. So in order to get the velocity, I need to do the integral. Integral of dv equals to integral of 4t cube minus 12t times dt. So v equals to 4t power 4 upon 4 minus 12t square upon 2 plus c. So velocity equals to t power 4 minus 6t square plus c. But at t equals to 0, v equals to 8. 8 equals to 0 minus 0 plus c, c equals to 8. So what is the equation of velocity? T power 4 minus 6t square plus 8 meters per second. The displacement of the particle from origin at t equals to 0. So in order to get the displacement, I need to integrate it. So ds equals to integral of t power 4 minus 6t square plus 8 dt. So which is t power 5 upon 5 minus 6t cube upon 3 plus 8t plus c. But we know that at t equal to 0, s equals to 0. It is at origin. T equals to 0, s equals to 0. So 0 equals to 0 minus 0 plus c, c equals to 0. So what is the equation? T power 5 upon 5 minus 2t cube plus 8t. Then find the values of t at which the particle is instantaneously at rest. Instantaneously at rest means velocity should be equals to 0. So for that, instantaneously at rest means velocity should be equal to 0. So what is the equation for the velocity? Equation for the velocity is t square t power 4 minus 6t square plus 8 equals to 0. So t square minus 2 times t square minus 4 equals to 0. So t equals to, or t square equals to 2, t square equals to 4. T equals to square root of 2, t equals to 2 seconds. And the question is asking find the value of t which is at rest. So either at root 2 seconds or 2 seconds. Coming to the last question. A particle p moves on x-axis. The acceleration of p at a time t is given by a equals to t minus 4. The velocity is given by v. T equals to 0, v equals to 6. Find v. So find the integral. Integral of dv equals to integral of t minus 4 dt. So v equals to t square upon 2 minus 4t dt. 4t plus c, not dt plus c. Now we know that t equal to 0, v equals to 6. So 6 equals to 0 minus 0 plus c, so c equals to 6. So what is the equation of velocity? 1 upon 2t square minus 4t plus 6. The values of t when the particle is instantaneously at rest. Instantaneously at rest means velocity should be equals to 0. So t square upon 2 minus 4t plus 6 equals to 0. So t square minus 8t plus 12 equals to 0. Factorize it, t minus 6 times t minus 2 equals to 0. T equals to 6 or t equals to 2. The distance between the 2 points at which the particle is at instantaneously at rest. So distance means integration. Integral of t square minus 8t plus plus 6 or plus 12. We can take that one as the integral between the times 2 to 6. Or else what we can do, we can take the original equation also. What was the original equation for the velocity? 1 upon 2t square minus 4t plus 6. 1 upon 2t square minus 4t plus 6. Either of this thing can be taken. We will be getting the same answer rather than we will be taking the original equation. So Find it out. 1 upon 2 t cube by 3 minus 4t square upon 2 plus 60 from 2 to 6. So it becomes 6 cube upon 6 minus 2 times 6 square plus 6 square minus 2 cube upon 6 minus 2 times 2 square plus 6 times 2. Simplify that. You will be getting negative 5 1 upon 3. So the distance is positive 5 1 upon 3 meters. That's going to be the answer. So that completes this questions based on past paper topic variable acceleration. So see you in the next video. Bye.